All right, so we're starting Module 4. So your learning objectives in 4.1 are to identify the population and sample in a sample survey, identify voluntary response samples and convenience samples, describe how to use a table of random digits to select a simple random sample, describe simple random samples, stratified random samples, and cluster samples, and explain how undercoverage, non-response, and question wording can lead to bias in the sample. All right, so what's the difference between a population and the sample? So a population is meaning every single person in the group is going to be taken into account. And so when we have a census of something, census tells us that we're dealing with a population. So for instance, if I interviewed every single employee at Park Hill High School or at Park Hill South High School, then we know that the entire population was taken. So that would be a census. It wouldn't be a sample. A sample is when we just use certain people. So maybe you just interview your teachers. And you just out of the whole population. So we use the sample to draw conclusions about the entire population. Because a lot of times it's impossible to get data from the entire population. So here you can see that a sample is a subset of the population. All right, we often draw conclusions about a whole population on the basis of a sample. So choosing a sample from a large, varied population isn't always that easy. There are several ways to take a sample, and there are several ways to take a bad sample. So we're going to learn some techniques to get a good sample. So always define the population you want to describe. Say what it is you want to measure. So are you taking a sample survey, a study that uses an organized plan to choose a sample that represents some specific population? And step 3, decide how to choose the sample. Okay, how to sample badly. Bias can occur when the survey sample does not accurately represent the population. So the bias that results from an unrepresented sample is called selection bias. So selection bias here, go back. All right, selection bias can be unrepresentative. So let's say that I only selected some people that's not a representative. So if you wanted to just have your group of friends, well, that could be selection bias. If you're only going to be taking, maybe you only have guys that are friends, or maybe you have girls that are friends. So if it's unrepresentative. So how can we choose a sample that we can trust to represent the whole population? Okay. Choosing individuals who are easiest, kind of what I was describing, that would definitely be a convenient sample. We do not want to do this. So convenient sample is bad. Just because it's easiest for the person who is taking the survey or doing the experiment. So you do not want a convenient sample. What about voluntary response samples? So you go to the mall and you say, hey, I need some people to help me, and you have a table set up and you say, you know, come give your opinion on this, and only the people who want to come give their opinion come. Okay, so this is people who are self-selecting themselves. And this usually will result in bias because it's only people with strong opinions that are usually going to be doing this. So only if they really, really care about something. So you're not getting the opinion of the average everyday Joe. Undercoverage. So undercoverage occurs when some members of the population are inadequately represented in the sample. So let's look at this. A classic example of undercoverage is the Literary Digest voter survey, which predicted that Alfred Landon would beat Franklin Roosevelt in the 1936 presidential election. The survey sampled suffered from undercoverage of low-income voters. So they went and sampled, but they didn't include all the really low income. from however they got their sample. So maybe all of the low income were out working and they only got to be sampled from people who were higher income. They weren't out working or something. And so those tended to be more Democrats. So that definitely threw it off, okay, by the survey that they took. All right, so how did this happen? Again, it could have been a convenience sample. So, oh gosh, what did they say? It said that they actually called telephone directories and car registration lists. Well, think about that. If you own a telephone or you own a car, you're going to be more wealthy, okay? So if you're more wealthy, then you're probably a Republican, sorry. And so it's going to sway the vote. So all of those people who didn't have telephones or cars were definitely in an undercoverage. All right, non-response. Sometimes individuals are unwilling to participate, and so you could have a non-response bias, okay? Or they choose not to participate. So respondents tended to be Landon supporters and non-respondents were Roosevelt supporters. Since only 25% of the sampled voters actually completed the mail-in survey, survey results overestimated voter support. Okay, so the non-response, the people who didn't own a car may not have got something, and so they were left out on purpose, or they may have just chose not to respond. Response bias. So response bias could be like, let's say that I say, how good of a teacher is Mr. Rose, and I stand over your shoulder while you complete the survey. Well, you're probably going to give me better scores than what you might have, but who knows, you may have given me the same ones. So, of course, you all marked great. But response bias, basically you're putting down what you think people will want, like social desirability. Or if it says, do you do drugs? And it's at a school survey, you're going to be like, no, I don't do drugs, because you don't want to get in trouble. The other type of response bias is if you have leading questions. So maybe the wording of the question led you to favor one of the responses. So this says, for example, a satisfaction survey may ask the respondent to indicate where she is satisfied, dissatisfied, or very satisfied by giving the respondent one response option to express satisfaction and two to express dissatisfaction, then they were biased towards getting a dissatisfied response. Okay. All right, so let's look at these. Which of the following statements are true? 1, random sampling is a good way to reduce response bias. 2, to guard against bias from undercoverage, use a convenience sample. 3, increasing the sample size tends to reduce survey bias. And 4, to guard against non-response bias, use a mail-in survey. All right. So none of the statements are true. Random sampling provides strong protection against bias from undercoverage and bias for voluntary response bias, but it's not effective against response bias. Convenience sample does not protect against undercoverage bias. So that's really bad, actually. You never want to use that. Let's see, mail-in survey does not prevent non-response bias. So in all of these, why they can reduce some bias, they don't reduce all bias, is basically what this is saying. For each of the following situations, identify the sampling method used, then explain how the sampling method could lead to bias. So, a farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. And the second question, the ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. There was no charge for calling either number. More than 186,000 callers responded and 67% said no. All right, so think about these. All right, so the first one is definitely a convenience sampling. Okay, they only looked at the top. This could lead him to think that the oranges are better than they would because the farmer could just put the best oranges on top. So they didn't really go through and get a random sample from the whole barrel. And the second one would be voluntary response sampling. Only the people who wanted to call in called in and they could feel more strongly. So if people are happy about the United Nations, they may not call in because they're not worried about it changing. because they're just happy the way things are. All right, a sample chosen by chance rules out both favoritism by the sampler and self-selection by respondents. So random sampling, the use of chance to select a sample, is the central principle of statistical sampling. You want to have a random sample. All right, a simple random sample, an SRS, this stands for simple random sample, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be selected. Okay. So a lot of people will use random number generators or a table of random digits. Your calculator, you could have a random integer. If you go to, let's see, what is it? Math, hit math under the alpha, go over to probability, down to number 5. So you can go math, probability, number 5. This is a random integer. So you could say you want a random integer between 1 to 8. And you could hit enter several times, and numbers could just start appearing. So it's kind of nice that your calculator will do that as well. That's what we kind of just talked about too. You could also say how many numbers you want by putting it in. So you could do a number between 1 to 6 and you want 4 of them. And this one actually came up 3331. Kind of odd, but be good if you were playing cards or poker or something. Okay, so there are several other ways to get random integers. There are websites out there. So this is a site that would actually give you random integers. Okay, so how to choose an SRS. So if you use a table of random digits, and your formula sheets have these, I think the back of your book, if you have a book or not, most stats book will have that. So it's kind of up to you, but on the AP test, they'll give you just a list of random digits, and you'll have to learn how to interpret those, and I'll show you that, okay? So they'll give you a string of digits. Each digit is equally likely to be chosen, and each entry is independent of the next. So each digit is independent. It didn't affect the previous one or the next one. So first what we would do is label our data. So we give them a numerical label, and these have to be the same length. So one data can't be 0 and one can't be 12. You could have 0, 0, and 12, but they have to be the same length. So 0 and 12 would be bad, but you could have 0, 0, and 12. That's good. Okay? And then you just would read the consecutive group of digits in the appropriate length. Watch out, if you've already picked it, you need to know whether you can have the same number twice or not from what's going on in your question. So let's look at this. Use the table below to choose an SRS of 6 or 4 different hotels. So they want to be different. So this was just a list of random digits. They go in 5 groups of 5. And they already assigned, they all have the same length, so they all have a 2 digits all the way up to the beginning. And you can assign them however you like. Alright, so now that I've assigned them their 2 digits, I'm going to pull the first 2 digits because I'm going 2 digits at a time. So 69 was too big, kind of made that a little. So 69 wasn't even on there, so it's too big, so I skip it. The next one I would pick is 05, so I pick Beach Castle. Then I pick 16, the Radisson. Then 48, too big. 17, the Ramada. 87, too big. 17 is the Ramada, which we already have, and it said 4 different, so again, I'm going to skip that. 40, too big. 95, too big. 17, we already have. 84, too big. 53, too big. 40, too big. 64, too big. 89, too big. 87, too big. 20, okay, there we go. So 20 would be the C club. And now I have 4. Let me erase what I have so you can see. It's kind of what they're doing. Might be easier to see than what I did. So they're taking you through on the PowerPoint, just like I did. Kind of had it this way. So again, 48 is too big. It has a little Ghostbuster sign on it. You already skip 17 because you already got it. And all the way until 20, and then you can stop. You've got 4 different ones. This is just a little joke again, just to remind you, don't forget to skip the numbers that you've chosen or were out of the range. So over here we have our random number generator, 9, 9, 9. So it's just kind of a little funny. Okay, haha. The basic idea of sampling is straightforward. Take an SRS from the population and use your sample results to gain information about the population. Sometimes there are statistical advantages to using more complex sampling method. So, one alternative to an SRS is called strata. So we could group with strata. These subsamples are combined to form one stratified random sample. So we can have an SRS, which means simple random sample, or now we could have a stratified random sample. Don't abbreviate that one, because you already used SRS. So a stratified random sample is first you're going to put populations into groups that are similar. Each of these groups is called a strata. Then from each of the strata, you're going to take an SRS, a simple random sample, in each strata. Okay, and then you'll take all of those SRS results for your full sample. So it's a little bit easier to see. So here you can see I have different strata, people that maybe go to different congregations or whatnot. From here, I take my SRS of whatever I selected, okay, SRS, and then I'm going to choose the people that are highlighted here as my overall sample. Sorry, that's not churches, those were schools. All right. So a high school student who is studying year 10, who is studying year 10 attitudes in the school, uses registration tuition classes as strata and studies a random selection of students from each of these classes. In a company, there are more men than women, but it is a requirement to have each group equally represented. 2 strata are thus created of men and women with an equal number of each. All right, so these are just showing you ways of why you would want a strata. Here, I'll let you read through this about stratification. You can pause me. When you're done, you can continue. Okay, so although stratified random sampling can sometimes give more precise information than a simple random sample, both sampling methods are hard to use when populations are large and spread out over a wide area. So in that situation, we want a method for individuals that are near each other. So we can use a cluster sample. Okay, so again, you're going to kind of divide the population into smaller groups, into clusters. Okay. Ideally, they should mirror the characteristics of the whole population. So you do not want them to have like characters. You want characteristics of the whole population. Okay? Not like characteristics. Like characteristics would be the strata. Okay? Then choose an SRS of the clusters. So you're going to have all these clusters, and you do an SRS of the clusters. Those tell you which clusters you're going to pick, and then you include everybody in that cluster. Okay? So everyone, all individuals in the cluster are going to be included in the sample. So that's different from strata. So think about this. Think about how you would use the following sampling method to select 80 students to complete a survey if you wanted to do a simple random sample, a stratified random sample, or a clustered sample. So you have 9th graders, 10th graders, 11th graders, 12th graders. So I'll let you think about that, how you want to write it down. You can pause me. So here, if you wanted to take a simple random sample, then you just would choose 80 seats out of all the numbers. So you could choose a random number generator, or you could go drop paper from a hat of all the numbers. You could use the random digits, okay? A stratified random sample is when you want to get students that are alike. So maybe all of the 9th graders are seated together. All of the 10th graders are seated together. So then with for all the 9th graders, maybe you're going to just pick 20 seats at random or 10 seats at random. Just make sure you take an equal amount proportionally for each. So if there's an equal amount of 9th and 10th, then you could do 20 and 20, but make sure it's a proportional amount that's equal. And then cluster sample, with the way students are seated, each column of seats from the stage to the back of the auditorium could be a cluster. So since there are 20 clusters with 40 seats, we need to choose 2 clusters at random to get 80 students. All right. So the purpose again for sampling is to give us information about the larger population, and this is going to be called inference. Okay, so I will let you read this. Basically, if you can get a larger sample, the more representative of the population you could have. Okay? So if you get a larger sample, you can decrease that margin of error. All right, so sample surveys are affected by errors in addition to sampling variability. Good sampling techniques include the art of reducing all sources of error. So don't forget, we had undercoverage, non-response, response, and wording of questions can all be bad. Here's another little joke for you. Okay, so that's the end of section 4.1. I know this module is a lot of definitions, so if you want to make little flashcards or something to help you out, but just to review the summary of what we've done, if you want to look over. Okay. And we will start in 4.2 next time.